Properties of logs. There are many properties of logs, but there are 4 big ones, and those are the ones we're going to focus on in this video. I'm going to spend a little bit of time on each one, but before we get started, I just want to review logs a little bit. If we have the log base b of x, they have a few components to them. That would be the base, and that would be called the argument. We're going to be looking at the base a lot in our properties of logs, as well as using the arguments. Now I want to remind you of our special cases if we have the log of x there and we have the natural log of x. Remember that when you don't see a base, that means it's the common base, the base of 10. And on this one, you don't see a base. Well, that's because it's the natural log, which means the base is e. That's the same as saying the log base e of x, but mathematicians and scientists use it so often that we go ahead and just write natural log of x. These are just some things to keep in the back of your head as we look at some examples of our properties of logs. This property looks at the product of arguments. So it says that if we have a log base b of 2 numbers multiplied together, or 2 things multiplied, we can split them apart and write them as 2 separate logs. The log base b of m plus the log base b of n. So we had multiplication and we're moving to addition. What's nice about the properties of logs is they work both ways. So let's see exactly why this works. Let's say we had the log base 2 of 4, and we were to add it to the log base 2 of 8. Using this property, we could say that this is the same as saying the log base 2 of 4 times 8, which is 32. So let's see exactly why this works. What is the power that makes 2 4? It's 2. What is the power that makes 2 8? 3. All right, now, what is the power that makes 2 32? 2 times 2 times 2 times 2, it's 5. So if we look, we had 2 plus 3, and that equals 5. So the property does work. The property does hold for this situation. Now, why would we even want to bother with that property? Because we might have an easy expression like the one we just had, log 2 to the 4, log 2 to the 8. So let's say we had the log of 225, and we were going to add that to the log of 4. Well, this one's not as nice. This is the log base 10 of 25 and the log base 10 of 4. Can you tell me the power that makes 10 25? What about the power that makes 10 4? It's a crazy decimal, that much I can tell you. So when we use our property, we can say that this is the log base 10 of 4 times 25, which is 100, which is the log base 10 of 100. So what's the power that makes 10 100? It's 2. This is why this property is handy. We can use it to rewrite logs in ways that we can evaluate. So, property number 1. So, our second property of logs is sort of the opposite of the first one. It's looking at a quotient inside of our argument. So, we have the log base b of m divided by n. We can split this apart by saying the log base b of m minus the log base b of n. And remember, just like the other property, we can go both ways. So let's look at an example to see why this actually works. Let's do the log base 2 of 16 minus the log base 2 of 8. If this property holds, we should be able to write this as the log base 2 of 16 divided by 8, which is 2. So now let's evaluate it. Let's see if this property actually works. The log base 2 of 16. What is the power that makes 2 16? It's 4. The log base 2 of 8. What is the power that makes 2 8? It's 3. Now hopefully this equals the power that makes 2, 2. What is the power that makes 2, 2? It's 1. 4 minus 3 is 1, so this property holds. And again, you're thinking, why did I need that? Well, let's look at a different example. So if we had the log base 3 of 21 minus the log base 3 of 7, we would have to ask ourselves, what is the power that makes 3 21? What is the power that makes 3 7? I can't think of any. When I think of the powers of 3, we're going 3, 9, 27, 81. It's not either of those two. However, if we utilize our property, because these have a common base, we can say the log base 3 of 21 over 7, 21 over 7. So we could say that we're looking for the log base 3 of 3. Well, what is the power that makes 3 3? It's 1. So we were able to simplify this complex log problem by using the properties to write it in a form that we could evaluate. So this was property number 2. The third property that we're going to look at has to do with powers of powers, more or less. So if we think back to our exponents, our laws of exponents, we see that we have the log base b of m to the n is the same as saying n times the log base b of m. So you see what we did was we took that power, we brought it out front, and it became a coefficient. This property is pretty handy, especially once we start solving equations where we have lots of variables all over the place. But we can look at an example to see why it would be necessary as well, just with numbers too. So let's say we had the log base 9 of 27. You really could solve this. You could figure out which power makes 9 27 by doing a little bit of complex thinking. But if we use the properties, it helps you kind of hone down where you need to go with your answer, because the answer is a fraction. So we have the log base b, or log base 9, of 27, which is really a number to a power. We could rewrite this as the log base 9 of 3 cubed, because 3 times 3 times 3 is 27. Now if we employ our property, we can take this power and it can become a coefficient and multiply with the log. So we have 3 times the log base 9 of 3. Now the log base 9 of 3 is not an ideal situation. However, what is the power that makes 9 into 3? Well, the square root makes 9 into 3. And the power that represents square root is 1/2. So we have 3 times 1/2, and our final solution is 3/2. The power that makes 9 27 is 3/2. So this property was handy because it got us into a place where we could go, oh, the square root of 9 is 3. All right, one more property to go. This is the change of base property. The change of base property is used a lot when you're solving. It has a few implications when you're evaluating as well, but I just wanted to show it to you. We'll use it more later on. Here we have, I'm going to start on the right-hand side. We have two logs being divided by each other, and they have a common base. Well, we can rewrite this quotient of logs as a single log by writing the log base b of x. Notice how the common base went away. The argument in the denominator became the base, and the argument in the numerator is the argument and the overall answer in the simplified solution. So the change of base allows me to take something that has a base and rewrite it as something with a different base. Like I said, this will come in handy when we're solving, but since we were talking about all the properties, I thought I'd bring it up now anyways. Let's look at sort of a sample of where we would see this. We had the log base 2 of 25, and we were to divide it by the log base 2 of 5. I don't know what the log base 2 of 25 is. I don't know what the log base 2 of 5 is. However, if we were to employ our change of base formula, these guys are the common base, so we can use this formula. We can say that this is the log base 5 of 25. The bottom becomes the base, the top argument stays the argument. So now we can answer the question, what is the power that makes 525? Let's do. So change of base has its uses when evaluating as well, but mostly we're going to see it when we start solving. So don't forget it. Keep it in the back of your head. It's a very important property. Earlier I said we had only one more property. I did the change of bases, and now I'm going to show you two more. These are sort of extraneous properties. These properties work because of those big four properties. So I just wanted to give you a couple of examples of why this is true. These are shortcuts. You do not need to memorize them. They will just make things a little bit faster when you start solving. So the first one, the log base b of b to the x is equals x. So the base and the argument are the same, except for the fact that the argument has an exponent on it. See why that works. The log base 3 of 3 to the fourth. Well, remember that property that we had before that said, oops, we can make that a coefficient. And we can say that this is the log 4 times the log base 3 of 3. Now, what is the power that makes 3, 3? It's 1. So this is 4 times 1, which is 4, which was the original power. That's why this one works, because of another property. But if you want to remember this one, that's fine. It will make things go a little bit faster, so you wouldn't have to do those steps in between. The other one is related to the same property. It says that if we have a base raised to the log of something with that same base, then the argument becomes your solution to the exponential. So if we had the problem 4 times the log base 4 of, I don't know, let's call it 16. This is 4 to the power that makes 4 16. If you think about that, sort of like a riddle, the power that makes 4 16, 4 is raised to that power, you can figure it out. I'm going to use an extra step to show that our properties still hold. 4 to the log base 4 of 16. What is the power that makes 4 16? 2. What is 4 squared? 16. So you can see the argument became the solution. Again, this property is true because of other properties. You don't have to have it memorized, but I thought I would show it to you so that you could use it in the future once we start solving. So now I suppose you're thinking, why do I have to know these properties? We're going to use these properties to do two main things. We are going to use these properties to expand, and we are going to use these properties to simplify. Expanding means I'm going to take one log and I'm going to rewrite it as the sum or difference of many logs. To simplify, that means I'm going to take lots of logs and I'm going to rewrite them as one log. This is going to come in handy when we start solving. I keep alluding to that, I swear. Everything is building up to solving. And you're going to want to have these properties down so that you can use them quickly and not get bogged down in the algebra of the problem. So let's do some expanding and let's do some simplifying based on our properties. So here we have one log. So we're going to expand it to write it as many logs as possible. So this is the log base 3 of 2 times x, or 2x. So here we have a product within the argument. We remember the very first property we learned said that we can split this up. We can write this as the log base 3 of 2 plus the log base 3 of x. Now you know you fully expanded something if there's no other way you can change the argument, if you can split the argument apart anymore. In this case, we end up with an argument of 2 and an argument of x. Those are both as simple as they can get. So this is the expanded form of the log base 3 of 2x. So again, we have one log. This means we want to expand. In this case, when we look at our argument, we have a quotient. So we have to use the second property. We can split this apart and say that we have the log base 4 of 16 minus the log base 4 of x. And again, if you are totally done simplifying, if you can't do anything else to the arguments. But we have the log base 4 of 16. 16 is a power of 4. So we can simplify that. What is the power that makes 4 16? The power that makes 4 16 is 2. So we can say that this is 2 minus the log base 4 of x. Now I don't think I can make x any simpler than it already is. So we've done expanding. We simplified the arguments as much as they could, all while writing it as many logs as possible. Here's another one that could be expanded. Right now we have a lot of stuff going on in that argument. We have 8 times x to the 4th minus 5. Or divided by 5. Look at me jumping ahead. You guys already know what I'm going to do. Let's break it up little by little. Let's just start out with the fact that we have quotients. So we have the log base 2 of 8x to the 4th minus the log base 2 of 5. Now let's look at our arguments. 8x to the 4th, that can be split apart further. So we could say that this is the log base 2 of 8 plus the log base 2 of x to the 4th. And then it would just say minus the log base 2 of 5. Now let's go to our arguments again. 8. 8 is the power of 2, so we can simplify that one further. What is the power that makes 2 8? It's 3 plus x to the 4th. That can be expanded upon a little bit too. We can take that 4 and make it a coefficient. Coefficients are bigger, expanding. And then that poor little log base 2 of 5 just stays as it is. So this final line here is fully expanded. We've used our properties as much as possible to simplify the arguments as much as they can. Our arguments are just ended up being x and 5, as opposed to the argument we started with, which was 8x to the 4th over 5. A lot more complex. So here we have more than one log. This means we want to simplify. We want to write them as one log. So we have a base of 2 and a base of 2, which means I can do this. So we have the log base 2 of x plus the log base 2 of y. We can use that first property again, but in the other direction. This is the log base 2 of x times y. This is as simple as it gets. I've written it as one log, so I can stop here. I only needed to use the one property. So this was simplifying, taking multiple logs and writing it as one log. This one seems a little bit silly, but I wanted to show it to you anyways because this will come up when we start solving. I have 2 times the log base 3 of x. Well, this is not the only way that we could write this problem. We can simplify it a little bit, make it smaller. We could write it as the log base 3 of x squared because of the property that says those powers become the coefficients and vice versa. This, again, doesn't do too much for me now, but it will come up when we start solving. So I didn't want you to forget property number 3. So what do you think? Expand or simplify? Yeah, it's pretty clear we got to simplify this one. We have a lot of logs going on. Now, in this case, it looks like I have some legwork to do before I even start writing it as one log. So we're going to do it step by step. I'm going to start with these coefficients. I'm going to say that we have the log base b of x cubed minus the log base b of x plus 1 to the 4th plus the log base b of y. Alright, we're moving along. Now I'm going to start with the first two. I'm going to ignore the last one for a minute. If we have the difference, that means we're going to use the quotient property. So we could say that we have the log base b of x cubed over x plus 1 to the fourth. My rule of thumb is if it's minus, it goes in the bottom, the denominator, plus the log base b of y. Alright, now let's put these last two logs together. This is adding, so we're going to use that product property, which was the first one. So we can say that this is the log base b of x cubed y over x plus 1 to the fourth. And we have simplified that thing as much as possible. We wrote it as one log. So again, these properties of logs are going to be very, very handy when we start solving. This one asked us to use almost all of our properties, our big properties, in the same problem. We were able to write 3 logs as one log, something that is going to come up quite a bit, writing many logs as one log. I keep harping on it, but it's really important. But just so you don't forget, the properties of logs are also handy when just evaluating. So let's look at one last evaluating one. Log base 16 of 32. What is the power that makes 16 32? I don't know either. However, we can probably deal with 32 a little bit. We could say that this is the log base 16 of, well, we could do this problem a couple different ways. 32 is 8 times 4. Or we could say that 32 is 2 to the 5th. We could also probably make up a division problem for this one too, but I kind of like that last one, the log base 16 of 2 to the 5th. If I use the power property, I can say that 5 times the log base 16 of 2, that simplifies there. Now what is the power that makes 16 2? So let me ask you this a different way. What is the power that makes 2 16? 4, right? So if we want to make 16 2, then we are going to be taking the fourth root. And the fourth root is 1/4 as an exponent. So this is 5 times 1/4, and our final solution is 5/4. We would have gotten the same thing if we had used any of our other properties, but I just wanted you to see kind of where they all come into play when we start simplifying. Alright, this is going to be a little review of our properties. We're going to use these 3 values at the top. We're going to have the log of 2, which equals A, the log of 3, which equals B, and the log of 5, which equals C. We're going to use these and along with our properties to figure out some different situations. Let's say we had the log of 6. I want to know what the log of 6 is in terms of A, B, or C. Well, we don't have the log of 6 up there. However, we can make 6 using some of what we have. The log of 6 is the same as saying the log of 2 times 3, which is the same as saying the log of 2 plus the log of 3. And we know what those two things are in terms of A and B and C. This is A plus B. Alright, so let's look at a different property. Let's say we wanted to find the log of 15 halves. Alright, well, let's start using our properties. This is the log of 15 minus the log of 2. What about 15? Can we do anything with that? 15 is 3 times 5. So we could say this is the log of 3 plus the log of 5 minus the log of 2. And now we can use, actually we know all 3 of those, don't we? So we have B plus C minus A. Cool. All right, one last one I want to look at. Let's find the log of 8. Think about your properties. Can you use your properties to get 8 in terms of either 2, 3, or 5? In this case, we could say that we have the log of 2 cubed. Use your property says that we have 3 times the log of 2. The log of 2 is a, so we could say our final solution is 3a. This was just a little bit of a review of all those properties. Remember, we have the big 4, but really we want to be concerned with simplifying and expanding using those properties in order to help us start to solve, which is coming up very, very soon. You can find some more information about the properties of logs by just doing any Google search and also checking out the Canvas page. Ha! You thought you were done. I just wanted to point out one little thing about our properties of logs. We were doing everything with the log base 2 and the log base 3, but don't forget about the natural log of x. The natural log of x is the log base e of x. All of the properties that I talked about hold for the natural log. So if we had the natural log of x plus the natural log of y, we could rewrite it as 1 log the natural log of x times y. Every single property works for the natural logs. We could even use our power property. We had the natural log of 9. We could say that that was the natural log of 3 squared. We could say that that was 2 times the natural log of 3. Everything still works. Nothing's different. You're just writing ln instead of log. But all of the properties, the expanding, the simplifying, everything stays the same. So you really want to just focus on those 4 main properties. Don't worry so much about the bases. As long as the bases are the same, you can use them. So, properties of logs work for natural logs too.